All right, guys, welcome back to session 2 from module 6. All right, upon completion of this module, you should be able to describe various non-destructive and destructive weld examination practices and describe welder performance testing process. Okay, performance-related tasks: perform a visual inspection on a fillet and/or groove weld and complete an inspection report. Okay, types of weld testing: visual inspection, liquid penetrant inspection, mag particle inspection, radiographic inspection, ultrasonic inspection, electromagnetic or eddy current inspection, and leak testing. Visual inspection criteria: proper cleaning, joint preparation and dimensions, clearance dimensions for backing strips, rings, or consumable inserts, alignment and fit up of the pieces being welded, welding procedures and machine settings, specified preheat temperatures if applicable, and tack weld quality are all part of visual inspection criteria. While welding, give attention to the quality of the root pass and the succeeding weld layers, the sequence of weld passes, inner pass cleaning, root preparation prior to welding a second side, and conformance to applicable procedure. Okay, undercut gauges. I'll bring these out also so you guys can see them. We have VWAC gauges, which actually can measure undercut and reinforcement, something that I'll do actually both of those when you do a qualification test. An undercut gauge is used to measure the amount of undercut on the base metal. Okay, but weld reinforcement gauge, be sure to read the correct scale for the measurement being taken. So this gauge actually is a two-part gauge. So right now what they're doing is they're measuring a fillet weld with this gauge. But on the other side, closer to the fingers, it's for butt weld reinforcement. So you can lay it on both plates, and then the sliding piece in the middle can be set on top of the weld to give you a measurement of reinforcement. Fillet weld blade gauge set. Okay, we'll get these out and use these. You guys will be able to see these. So if you look on the left there, that gauge for the 5/16, the one that kind of has the two dishes with the bar in the middle that's being shown there now, that's for measuring a concave fillet weld. And on the right, it's measuring convex. Okay, so it's a little easier to measure convex versus concave, but they both will measure it. And this tool is used widely in inspection as for visually inspecting fillet welds. Okay, liquid penetrant testing. I have some of this, and if I can find the part, I will bring it out and demonstrate this for you. So basically what liquid penetrant inspection, it's a non-destructive method for local defects that are open to the surface. It cannot detect internal defects, so it's for cracks. So what you do is you spray a penetrant on there, which is the left can here that's shown. And you spray a cleaner and you wipe it down, so the only place penetrant would be is within a crack. And then you spray the developer on there. And what the developer does is it kind of turns the whole surface white, and then where the actual crack is, it turns that red, so that you can actually see exactly where a crack is or has occurred. Okay, leak testing. Leak testing is used to determine the ability of a pipe or vessel to contain gas or liquid under pressure. Okay, so the basics of this is it's just brought up to a certain pressure and held there, and you know, the source that's feeding the pressure in there is then disconnected, and there's a pressure gauge on there that just looks to see if the pressure drops at all. And then you could use soapy water to detect where the leak is and where the repair would have to be made. Okay, another inspection method is a mag particle test. These used to be widely used also in the engine building industry. So my car guys in here, this is something that when we had all cast iron engines that you would use. What it does is an electromagnet, and when you put the two poles on the plate, and charge that electromagnet. Then what happens is if you have any cracks in the surface, you actually dust a fine metal filings, some fine metal filings onto the surface that are colored like a bright yellow or bright green. And what'll happen is those will actually kind of fill in the gaps, and so then you can see exactly where the crack are because they're held in place by the magnet. These are used in multiple industries. Okay, eddy current testing. These are advanced testing methods. I don't know, I've shared with some of you that I'm a CWI. To be able to inspect some of these advanced visual inspection techniques, I'd actually have to work under someone for multiple years. I think it's somewhere around 1,000 hours plus passing some additional exams. So this is where I still have a lot to learn, is eddy current testing. Looks at electrical current, the currents passed through a weld. Radiographic testing, this is like an x-ray, guys. Some of our guys that work in the oil fields can share some experience with this. But I mean, basically it's just like when you get your leg x-rayed, or, an arm x-rayed when they think you broke a bone. The thing is x-ray tests, sometimes improper joint prep can actually cause a failure on an x-ray test. So again, it's super important that you prep the plates correctly prior to welding. Ultrasonic testing. So what we're doing here is we're bouncing a beam of sound through the weld. If there's a flaw in the weld, it'll bounce back at a different rate or different tone. This is basically ultrasonic waves similar to an ultrasound, right? Passes through the metal being tested and are reflected back by any density change caused by a defect. The reflective signal is shown on the screen display of the instrument. Destructive testing. So basically, destructive testing is exactly what it says. We're destroying a part so that we can test the strength of the weld. Okay. The non-destructive testing is very important so that we can inspect things that are built, steel frame coasters, buildings. We need to be able to inspect those and leave them there. We can't be cutting parts out of them to destroy. But when we test to qualify procedures and personnel, we can do that and destroy the weld. So in destructive testing, the test sample is destroyed or damaged in the test process and is no longer suitable for use. Destructive testing is often done in the laboratory setting. Okay, guided bend test. Okay, this is what we're going to do for qualification. I have some samples I'll bring into the classroom for you guys to see. When we do a 1-inch plate, we'll do a side bend like shown on the left. The top left, the one on the right and the bottom left, those are face and root bends. When we do a practice plate at 3/8 of an inch, we'll do face and root bends on those. Okay, here's a bend tester. I'll show you the one we have. It's slightly different, but it performs the same function. A fillet weld break test. The load is put there. The fillet's only welded on one side. Ideally, if it breaks correctly, there'll be a crack right down the center of the fillet weld. Weld positions for plate. So 1F position for flat plate is shown here. So a fillet weld, if you're doing a T-joint, the fillet will be in the shape of a V. 2F for horizontal. This leaves one plate of the T-weld flat and then the other one vertical. 3F. Now both plates are kind of in a vertical orientation, but the axis of the weld, so if you drew a line in the direction that the weld was going to move, it moves vertically. 4F is overhead. And then for fillet welds, the F is for fillet welds, the G would be for groove welds. So 1G is flat, 2G is horizontal, 3G is vertical, 4G is overhead. A couple things to remember. If you pass a 3 and 4G qualification test, they will cover you for 1 and 2G. Okay, weld positions for pipe. Okay, so with pipe, so you can do a fillet on pipe when you have a slip joint like it's shown on some of the pictures on the left, or if the pipe's being welded to plate. But let's look at pipe to pipe welds. So 1G rotated, so that means the pipe lays horizontally, but then it's rotated around and the weld's done while the pipe rotates, so all the weld actually happens on the top of the pipe. 2G horizontal, the pipe is in a vertical direction, but the groove being welded is horizontal. 5G is basically like 1G, except the pipe doesn't rotate. So for 6010, depending on the code, you'd start at either the bottom or the top and weld each side of the pipe. And then the 7018, after you do your root and hot pass, would all be welded starting at the bottom, welding up. 6G, now the pipe's at a 45-degree angle, and the groove weld is also at an angle. This is the most difficult, but this is truly the kind of the holy grail of pipe welding right here. 6GR, says rotated. Actually, it's restricted. So there's a restrictor plate on there that limits the amount of movement that you have to manipulate the electrode. Okay, AWS structural steel code, qualification with an electrode in a particular F number classification will qualify for the welder with all electrodes identified in classifications and in lower F number classifications. So we look at an F4. This includes E7018. This is what we do all the groove plates in, so it covers us for everything else. F4 is considered the most difficult group to weld. F3s are 6010, 6011. You know, they make 7010, 8010, other rods out there. You know, and then F2, you know, we're looking at our rods with a 12, 13, or 14. And then F1s, you know, these are like 7024 jet rod, welds really well flat or horizontal fillets where you need a lot of fill, but, you know, kind of an easier rod to weld. Okay, here's a typical AWS test plate coupon. This is a limited thickness test as shown here. A typical AWS welder qualification test is a V-groove weld with backing in the 3G and 4G position using an F4 electrode. Passing this test qualifies the welder to weld with F4 or lower electrodes and to make a groove and fillet weld in all positions. ASME Code qualifies on pipe, also qualifies the welder to weld plate, but not vice versa. ASME is going to be typically pressure vessel. If you're welding out in the oil fields, they're going to all go by API 1104, which is the code for the Petroleum Institute. Once you enter a refinery, though, it's my understanding that then you are under ASME code. Welder qualification for material up to 3/8 of an inch thick. A face and root bend are required. For thicker material than 3/8, 2 side bends are required. As outlined here, you guys will get lots of practice at doing this. Preparing specimens. Poor specimen preparation can cause solid weld metal to fail. Okay, it's important that everything's ground smooth and the edges are slightly rounded. And we don't want to take off too much material. If you're turning in a 1-inch plate to weld and you have an inclusion you're trying to grind out and your weld area that I'm going to bend is only 5/8 of an inch thick, it's going to fail. Okay. We're not going to do the section review. You guys can work on this in the review quiz online. Please complete the review quiz and the trade terms quiz and prepare for the test next class. Thank you.